All right, in this problem, we are looking to identify all of the trigonometric ratios. They're going to be a total of 6. This is your sine, cosine, tangent, cosecant, secant, and cotangent. And really, this isn't too bad normally, but two things on this one. We've got a radical here, and that kind of scares me just a little bit, but it's not too bad. And then we don't know the hypotenuse. So what we're going to do first is we're going to identify this missing side, this hypotenuse. And we can identify that because of this right triangle. So on this right triangle here, I can use Pythagorean's theorem to identify what the hypotenuse is. And a squared plus b squared equals c squared. Well, a and b are my shorter sides, these two, and c is my hypotenuse. So we're just going to plug these in. Okay, so a is 18, so 18 squared plus 2 square root of 19 squared. Okay, is equal to c squared. Now, this gets a little bit daunting. We know 18 squared. We can just plug that one into our calculator. No problem there. But this 2 square root of 19 squared, what we're going to do here, that's really just saying 2 square root of 19 times 2 square root of 19. So 2 times 2 is 4. Square root of 19 times square root of 19 is just 19. Okay, so now we have 4 times 19. So 4 times 19 gives me my 76. Okay, so we've got 18 squared, which is 324, plus 76 is equal to c squared. So 324 plus 76 is going to give me 400. And then we take the square root of both sides. C is equal to 20. So this hypotenuse side has a length of 20. Well, now that we know that, we can just set up our trig functions, right? All right, let's go into our ratios here. Sine is the opposite side divided by the hypotenuse, and it's all in relation to theta here. See how this is sine theta? Here's my theta. The opposite side, let's see, that's going to be the one furthest away right here, 2 square root of 19 over 20. So let's put that here, 2 square root of 19 over 20, and I notice right away that I can reduce this. I've got a 2 divided by 20, which is the same thing as 1 over 10. So 1 square root of 19 divided by 10. Of course, we don't write the 1 in front of the square root, but this would be my sine ratio. Cosine is the adjacent side, so that's one that's closest to theta here. The adjacent side, 18, divided by the hypotenuse of 20. 18 divided by 20, of course, can be reduced. This would be 9/10. Tangent. Tangent is the opposite side divided by the adjacent side. So I've got 2 square root of 19 divided by 18. Now, just like my sine here, this can be reduced. I've got 2 and 18, which is 1/9. Of course, we don't write the 1 in front of it. Okay, so far we've got 3 of them. This is good. And the next 3 aren't quite too difficult either because they're all reciprocals of our previous 3. Okay, let's go through this one. So cosecant is actually the reciprocal of sine. So all it's going to be is hypotenuse divided by opposite. That's not too bad. Or we can just take this one and flip these two. Sometimes I refer to these as the refliprical, just to kind of remind me that's what a reciprocal is. We are flipping these two, okay? All right, so we've got this one, and this is our original one, and we've flipped these two, which is great, but the problem is I got 2 things. This 2 and 20 can be reduced, plus I cannot have a square root on the denominator, on the bottom. So what I'm going to do to get rid of that one is I'm going to multiply top and bottom by the square root of 19. Now we haven't changed the value because the square root of 19 over the square root of 19 is just 1. So we're multiplying this by 1, which doesn't change the value. But what it does is it'll move this radical to the top. Okay, so now we've got 20 times the square root of 19 all over 2 times 19. Well, I can see right away that this 20 and 2 can be reduced. So I do that now. So this is my final answer here. All right, now we're going to do, for our secant, it is just the reciprocal of cosine, which is 10/9. That one's an easy one, okay? And tangent gets to be a little bit more complicated, similar to what we did up here. We're going to do the exact same thing down here. We end up with a radical on the bottom. And when we have the radical on the bottom, all we need to do is multiply top and bottom by that radical. And in doing so, we end up with just moving that radical on the top, okay? And this would be your final answer here. Now notice on this one, I didn't use the original one. I just used this one. You can do that, that's fine. Then it just saves you from reducing at the end. Most of the time what I do is I just take the answer and then I flip these two. And that's where I start. It just saves me a step is really what it is. But these 6 that I've just circled are your answers for this one.